So remember, we have the full playlist for these videos. We have Dr. Bean's videos, and we have several other voices on this topic. There are so many good chemistry YouTube channels. So those are represented in those videos. Remember, if you start listening to the videos and like someone, just Google their name and the topic, and you will probably find more videos on it. These are active links right here and here if you need to get to the chapter in OpenStax. So let's talk about two kinds of bonding. So there are two kinds. What you have in the one case is electron transfer. So you're making ions when you do this. We'll do some examples of it. And the other one is covalent, which is electrons sharing. Cohabitate, co together, so they're being shared. And it has this word called orbital overlap. And that will be discussed more thoroughly in Chapter 5. Like all of chemistry and general chemistry, you learn part of the story here and part of the story there, and then you look back and you say, wow. Also, in other classes, you may learn about ionic bonding and covalent bonding. And what you should know is that ionic bonding is stronger than covalent bonding, except in the case of network covalent bondings. Especially if you're in geology, you'll come across network covalent bonding. That is stronger. It's obviously a network of bonds, so lots of bonds makes things stronger. But you should think of an ionic bond in general chemistry, because we're not talking about networks, as being stronger than covalent bonds. So let's look at how they look. Let's look at what's going on. So we already know that sodium, it's a metal. It's on the left side of the chart, and it's in the first column. So that implies it likes to lose just one electron. So you can see in here how it becomes positive. Remember, we learned in the last chapter that when it becomes positive, it gets a little bit smaller due to effective nuclear charge, and also due to the number of protons that are pulling on the electrons in that nucleus. All right, so then we also have the chlorine. Chlorine is the second to the right column, and that column likes to gain electrons. And so remember, also in the last chapter, it becomes negative. So what happens is that these two, once one has lost an electron and one has gained an electron, usually it's the same electron. So usually when he loses this electron right here, so he was here, he loses it, it usually then goes to him. It's the same electrons, not like random electrons. Usually they're close enough and there's some energy money being transferred that's allowing that to happen. All right, so then just like anything that's positive and negative, you already know those. You know the positives and negatives attract, and that's what happens. So you've got to lose the electron, you've got to gain the electron, and then you have charges. Once you've got that, what happens is these are so small that when you look at them on an individual level, they actually start to form these cube-type structures. Those are the two that we were just looking at, and you'll see that, like the red one is the sodium, you'll see that this sodium, like I'm going to look at this sodium right here, you'll see that he's actually touching 1, 2, 3, 4, and then if you go inside the molecule, he's also touching some chlorines. So to make things simpler, so we don't have to draw cubes and all those circles and everything, we will notate it like this, but you should be aware that it forms these cube structures. This is why salts are easy to crack. They have different fracture lines and stuff that'll make it really easy. Salts and just anything that forms crystalline structures. You can form crystalline structures in the other situation also, but things that are cuttable or shearable and it breaks into these sharp edges and pieces, they usually are coming from an ionic kind of a background like that. All right, so then we'll look over here at covalent molecules. And so these are the molecules that have, or the atoms that share electrons. And so in this picture, you'll see there is an electron here. I can see if I can get it a little darker or maybe brighter. There's an electron there and there's an electron there. And so what happens is they both actually want 2 electrons and they each only have 1. Neither wants to give it up. So for various reasons, and most of the time we're talking about the right side of the chart. So this is the side of the chart that kind of prefers to go negative if it were going to form ions. And so obviously you don't want them both to be gaining electrons, because then they both will be negative. And then they won't be attracted to each other. So this is a different kind of bonding. And what it is these molecules get closer and closer together, and then they overlap, and those are the nuclei. So there's a nuclei and there's a nuclei. And their electrons can kind of get into each other's space. And so his electron here also feels this nucleus. And then this one's electron also feels that nucleus. So these electrons are shared and they form the covalent bond. And what happens is it's kind of like both elements claim. So say we're talking about this one. He claims both of those electrons as his own at any point in time. But then he claims both of the electrons as his own at any point in time. It's kind of crazy. When you get into the way that covalent things look, and like I said, they can form crystalline structures also. These are lattice structures though, and that's a little bit different. These ones have this kind of a look. So if you've ever seen chemistry pictures before, and they've got like these really cool shapes, those are doing covalent bonding where they're sharing the electrons. We'll learn a lot about this later on in the chapter. We are not overly focusing on these. You can, and maybe you would end up in a chemistry course where they did focus on things and they have you learn things like face-centered cubic and such. But we aren't going into that. We are just going to be focusing on this. As an aside, there is another type of bonding that happens, and it's metallic bonding, and we are also not discussing that. But if you're curious about metallic bonding, you can look it up on the internet. And it forms kind of sort of a structure that may have a look kind of similar to this, but it's different. And metallic bonding has a sea of electrons. So it kind of is full of these electrons that are moving all over the place. And of course, that's going to be metals that do that. So let's focus. We're going to first focus on ionic bonding and then covalent bonding, and then we're getting to naming, and then we'll get into shapes. So which